Hi students, in this exercise they give us a real bar which is in equilibrium, in a static equilibrium. So they say what are the magnitudes of the forces F1 and F2 that are acting on this massless rigid bar, right? So what are we going to do to solve this exercise? Well, we know three equations of equilibrium that we can use when we're working in two dimensions. So we can find a sum of forces with respect to the x-axis, and we know that this sum of forces will be zero. Usually we take positive the forces pointing to the right. We're gonna have a sum of forces in the direction of the y-axis, right, equal to zero. Usually here we are taking positive the forces pointing outward, and we're gonna have a sum of the torque with respect to a point on the read bar, and that sum of torque will be equal to zero, and then usually we take positive any torque that is counterclockwise, right? In this case we don't have any force acting on the direction of the x-axis, so we're not going to use this equation, right? So we have then two equations to solve the problem. So the first we're going to do here is to apply the sum of forces in the direction of the y-axis, right? So we say that the sum of the forces in the direction of y equal 0, and we're going to be taking positive forces pointing outward, right? So what forces we have here? We have the force of 40 newtons, which is pointing outward, so it's positive, minus the force 1, that is going to be negative because it's pointing downward, plus the force 2. And this is then equal to 0, right? So we don't know here force 1, and we don't know the magnitude of the force 2, so we have one equation and two unknowns, right? So what are we doing now? Now we're going to apply the sum of the torque with respect to a point on this rigid bar. So I will call point A, this point over here, where is the force of 40 newtons acting. I will call this point point B, right? That is the point where the force of F1 is acting, right? Or is just located. And then I will just call point C, this point where the force F2 is applied, right? So when we are solving a problem like this, and we're going to use the sum of torque, what are we going to do is just to make the torque with respect to a point, you know, for which one of the unknown is passing through, right? So we can just make the torque either with respect to point B, or we can just find the sum of the torque with respect to point C. In this case, I did it with respect to point C, right? Now, we're going to say that the sum of the torque with respect to point C is equal to 0, and then we're talking counterclockwise positive, right? So with respect to point C, the force F1 is making a torque, right, that is counterclockwise, right? Okay, and the torque due to the force 1 would be equal to the product of the force 1 times the distance from force 1 to point C, and that distance is 1 meter, right? So we will have force 1 times, you know, the arm or the distance from force 1 to the point that we are just taking, you know, as reference to make the torque. So this is just 1 meter, and it's positive because it's a torque counterclockwise. Now the other force that is doing torque with respect to point C here is the force of 40 newton, right? But the torque due to this force is going to be clockwise, right? So this torque will be negative. You know, we said that the counterclockwise was positive, right? And this torque will be then the force of 40 newtons times, right, the distance from the force of 40 newtons to point C. So it will be 2 meters plus 1 meter, right? And this is going to be equal to 0, right? So now we can say that force 1 is equal to 40 newtons times 2 plus 1 is going to be 3 meters divided by 1 meter. The meters are going to cancel out, and then we're going to have 120 newtons. The value of the force one that we got here is positive, so that means that the direction that we assumed for the force one was correct. So force one is a force pointing downward, so I can express the force as a vector as F1 vector is equal to minus 120 J, right, in newtons, right, minus 128 in Newton. So remember, you know that the axis, the unit vector in the direction of the y-axis is the unit vector j, right? Now we're going to substitute the value of force 1 that we found here in this equation, in the equation that we found previously, right, about the sum of the forces in y. So we're gonna replace F1 by 120. So when we do it, okay, we're going to get here by substituting in this equation 40 newtons minus 120 newtons plus F2 equals 0. 40 minus 120 is minus 80 newtons plus F2 equals 0. So F2 will be equal to 80 newtons. We got F2 positive, right? So that means that the direction we took for F2 is correct, or the direction that was given in this case for F2 is correct. So we can express F2 as a vector as F2 vector equals to 80 J newtons. So we have this force in the direction of the unit vector j, right, in the positive direction of the unit vector j, and is equal to 80 newtons in this case. So we found in this case both forces, F1 and F2, right, with magnitude and direction. Okay, so the exercise was solved. Again, I invite you to subscribe to my channel and support my work, right? And you will get notifications of every new video. Thank you so much for your attention.